This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 1, Lesson 8, Sensible Heat Ratio and the Process Line. The sensible heat ratio is just the sensible share of a load, sensible over total. But it does something visual too. It fixes the slope of the room's condition line on the chart. A flatter line means a mostly sensible load. A steeper one means more latent. We'll define it from the printed shortcuts, draw the line, split a real load, and size the supply airflow. Concept 1. What it is. The sensible heat ratio is sensible load over total load, a fraction from 0 to 1. Build it from the standard air shortcuts, and the airflow cancels, which tells you SHR belongs to the load, not the fan. And all sensible load gives 1. The more latent it carries, the lower it falls. Comfort cooling usually sits around 3/4. Concept 2. The process line. Put a line through the room point at the load's sensible heat ratio. The dashed horizontal is pure sensible, an SHR of 1. The load's SHR tilts the real line down from there toward the supply state. Flatter means more sensible. Steeper means more latent. That's the whole picture, read straight off the chart. Concept 3. 2 lines, not 1. The room load has its own sensible heat ratio and its own line, which sets the supply state you must deliver. The coil has a different sensible-to-latent duty, so its line tilts differently. They meet at the supply air point, but never share a slope. Size each from its own split, and don't read the room line off the coil. Setup. A space carries 250,000 total at a sensible heat ratio of 0.75. Supply air enters at 55 into a 75-degree room, so the sensible temperature rise is 20. The plan? Split the load with the ratio, then invert the sensible shortcut to size the airflow. Solve. Part 1. The split. Sensible is the ratio times the total. 0.75 of 250 is 187,500. Latent is what's left, 62,500. Their ratio is 3 to 1. Notice the same load reads as a fraction of 0.75 or a ratio of 3. Don't confuse the two. Solve Part 2. The airflow. The air warms from 55 to 75, a 20-degree rise, so invert the sensible shortcut. Sensible load over 1.10 times 20 gives about 8,500 CFM. Cross-check the latent load with that same airflow, and you get a humidity ratio drop of about 0.0015. One airflow carries both loads. That is what a single condition line means. Traps. 5. 1. Sensible heat ratio is a load ratio. Bypass factor is a coil property, and it isn't even in the handbook. 2. The room line and the coil line have different slopes. Don't swap them. 3. SHR is sensible over total, not over latent. Mix them, and 0.75 becomes 3. 4. A flatter line is more sensible. A steeper one, more latent. 5. One airflow carries both loads on a single condition line. Quick recall. Sensible heat ratio is sensible over total. And on the chart, it's the slope of the room's condition line. Flatter is more sensible. Split a load with it, then size the airflow from the sensible shortcut. Golden rule. It's a load fraction over the total, not the sensible-to-latent ratio, and not the coil's bypass factor. Next up, Lesson 9, Altitude and Low Temperature Corrections. Every shortcut so far assumed sea level air. Thinner air at elevation drops the constants. 1.10 becomes 0.92 at 5,000 feet, and the chart shifts to. Everything's at peprepengine.com. Cheat sheet, worked solution, and a quiz attached here.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.